Let's go ahead and get started. So today we figured we'd do something maybe a little bit less formal. As you can see, I've got my hat on backwards and I'm sitting at my kitchen table, which is how I usually code when I'm in the middle of doing something interesting. I've got my crew with me. I've got Scott Pfister and Jay Wood, two incredibly smart human beings, both principal engineers at Seven Factor. And so what I want to talk about today and sort of the idea behind this webinar is let's jump into some code and let's use some agents to do some real things. I did a similar presentation to a local healthcare firm here in Atlanta. It was a lot of fun. I couldn't get through the whole amount of things I wanted to because we also had some concepts to talk about with respect to what are the feedback loops when we're doing AI-based agentic development, et cetera, et cetera. But I want to show people sort of how I've been using agentic for my local usage. And I have a little side project here. I like to grow microgreens, if anybody knows what that is. It's delicious. Little tiny baby plants. But there's actually a very deterministic way to do this, and there's a branching on how you want to grow things. And so I have created using Claude. This is entirely Claude coded. I created this project that came that I pointed at an existing project I already had. And this is very important to think about. So I have a bunch of code that I've written through the past 2 decades of my life. When I started Seven Factor, I had a specific way that I wanted to do things with Docker containers and local running machines. And so basically the premise is I want to run a command and have an entirely working and running API at my fingertips on my local machine, right? So I have a bunch of projects and I started Claude up and I described to it what I wanted it to do. I wanted it to look at the following paths and I wanted to build out an API in Golang because I like Golang. Why not? That solves a few specific problems that are related to my whole microgreens growery or my microgreens growing nursery, which I have in my basement. And so it came up with a really well-formed API and it actually created this make file, which is a little bit bloated, to be frank. I could probably remove a lot of this stuff and not really care about it. But it has a very well-defined set of commands, and they all work. They worked kind of the first try, which is great. Now, caveat, I've not run it in probably 3 or 4 days. So if I run make test all, it might all break, which I think is a fun experiment. Let's try that. What make test all does is it boots up the API container, it builds it, it boots up the API container, and then it runs unit tests against it, which are standard unit tests that don't actually touch any running systems. And then it boots the entire Docker Compose system up and it seeds the database and it actually runs integration tests against the API that go all the way to the database and back. But first, let me do a make Docker reset just to make sure we have clean, squeaky clean containers. All right, it's doing the thing. And so what we're going to do today while it's doing that is I have a feature that I started to implement maybe a week back, but I completely walked away from this project and had other things to do and forgot about it. And this is actually an interesting use case, I think, for us to discuss in that the feature is partially implemented and it's my own fault for not putting this on a branch and doing a good job of like getting the full feature implemented and pushing it into main. But this is a less than ideal situation. But frankly, this is an area where I think AI is quite interesting and useful. Is when you walk into a situation that's less than ideal, and you want to figure out how to use the tooling to get the best out of the situation. So, for example, maybe this is a legacy code base that you're walking in and you're having Claude read the context of the legacy code base and then starting to kind of build a mental model of the code. I want to show you how I built a mental model of this feature because I completely forgot how it was implemented, and now we're going to work together to implement maybe a piece of this or make some changes to it. So let me just, again, first make test all. If the tests don't run, you know what? We'll just use that as a part of the experiment when we're actually implementing the changes. We'll just tell it, no, by the way, the tests don't work. Please fix them. He usually does a pretty good job at that. And with that said, Jay Wood, Scott, do you guys have anything you want to add or any specific things you want to add to this experiment while we're doing this?
No, but I will say I think it's really great to have that concept of that make file with all those different things that it can do. You can just throw that kind of that the help alone almost there, and then say, hey, build me a make file that does this, and that's really kind of a great way to interact with AI because it provides such self-documenting tools. That's why a lot of people talk about
Yes.
CLIs over MCP, which isn't necessarily always true. But the idea that you have a tool where you can just do dash dash help or something along those
Mhm.
lines, it figures it out and then it uses it, and it's very purpose built. It does exactly what you need to for your project.
My favorite
Yeah.
thing so far, sorry, Jay, but my favorite thing so far about this entire experience is it spins up tooling like that. I was a notorious bash scripter back in the day where I would spend, by the way, all my tests passed, 458 tests. I spent so much of my time just writing bash scripts to automate how my local environment works. This is incredibly strong to have this thing build out this make file. And I've had to iterate on it maybe once or twice to get it right to a position to where it works. All right, go ahead, Jay.
Yeah. So the thing you mentioned about the bloat in the make file, I think that's something I see commonly using AI like this. It'll often give you kind of more than you need because it's like this is I don't know, best practice. But like that may not apply for your situation. So
Right.
it is good to look at those and like, consider is this helpful? Because a lot of times pruning that unuseful stuff, the things that are not relevant, will
Mhm.
actually make the agents work better.
Yeah, for sure. It will. I agree with that 100%. One of the things we were going to talk about during this experiment is that there's really two feedback loops in my mind. And this may be trivial to people who have done this, but sometimes you just speak it into existence and that's good enough. The first feedback loop that we're going to operate on is the output of the machine. That is the code that's being produced as we're working. It's, I just noticed some of my integration tests fail. All of my unit tests have passed 458 unit tests and took a minute. We could probably do an optimization pass on that. That seems a bit too slow. And then I had a bunch of what appears to be integration tests fail. We'll give those a look in a minute. We had 7 fail against 106 tests. So something's going on, probably a seed script, I'm guessing, if I had to think about it. But the second loop is the loop in which you're prompting the machine, right? So no longer used to, when you did red green refactor, if anybody remembers that, we'd sit in front of our computer, we would write a failing test, and then we would write the production code to make the test pass. And then what would we do? Words are hard. Is you would simply refactor that code, and that's the strength of the test. A lot of people misunderstood that from TDD. They're thinking that TDD is all about writing the test first. It is from a process perspective, but the point is that you can refactor and you can look at the code that you wrote that passes the test, and then you can make it better and iterate on it to make it more maintainable. Similarly, when you're working in Claude and Agentic, I've found having that loop on your agent is actually super useful in that you look at what the agent has done. And per what Jay Wood said, you do have to assess the current context state of the agent. I'm always thinking of what does this agent know and how is it interacting with the code base? And do I need to blow it away and start over? Or do I need to build on the context that's already there? Because as we know with these algorithms, if they're biased towards an outcome, they'll almost always continue to bias toward that outcome until you tell it, hey, hold on a second, start over, blow your brain away, and let's start over and try again. Okay, my tests fail, but whatever, we can deal with that in a moment. Again, I'm not particularly worried about it quite yet. So let's go over here to what I asked this thing to do with my brand new code base. So there's this concept in when you're growing microgreens of a life cycle, and very briefly, I want to explain the first concept that's important. It's called a loadout. A loadout, very simply put, is a tray. It's a little tray that's maybe 1/4 of an inch to 1/2 inch of an inch thick. You fill it with dirt, and then you put your seeds on top, and you water them down, and then you get them to germinate, and then they go through what's called a growth cycle. A loadout is what tray are you using, what type of medium are you using, cocoa coir, dirt, hydroponic, blah, blah, blah. What seed are you using, kale, broccoli, blah, 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 peas, and then finally, how much of that seed, based on a weight, are you going to put onto the medium to grow the plants, right? And there's actually a very tight tolerance on how much seed needs to go into a particular tray based on studies that are done in professional microgreens growing nurseries. Too many seeds and the entire crop will crash and it will all die. Too few seeds and you're not getting enough yield. So it's an interesting optimization problem where you have to kind of figure out what the right amount is. So given a loadout, which has been implemented and implemented very well, aside from my failing tests, which we'll deal with in a moment, this is the concept of a growth cycle. So what I did is I booted up Claude and I said, hey, Claude, remember when I was implementing that growth cycle thing? I don't remember how far we got. Can you please read the code, reassess the current data model, and figure out and explain to me where we're at and the concepts that were implemented by the machine? And here's the output. It's kind of an interesting thought exercise here. A growth cycle is a single batch of microgreens from planting to harvest or failure. That is in fact very true, right? Here is the life cycle. We go from a loadout to what's called a snapshot. And notice that it calls out the snapshot pattern, which is a very common pattern in database design and also API design, where you have a template that turns into an instantiation of that template, then has a state machine that sits on it and kind of moves that through various states to track it. It's, again, super common pattern. The growth cycle is created. The first, I actually really like how it drew this out. I like that. The first question is a soak required? If yes, then we soak. Then we go to germination. Then we go to blackout. Then we go to active growth and harvest. Or we go from germination to active growth to harvest because there's no blackout. Or we fail because the germination failed. That's pretty clear. That makes perfect sense to me. If a soak is not required, then we simply copy paste this section of the tree. I can't draw that section of the tree. That is exactly the right mental model. There's a couple of caveats here. There's what's called a watering cycle that's not taken into account here, but let's shelve that for now, and let's continue to think about this. So the creation flow: a user picks an existing loadout. That's correct. System snapshot all the loadout config into a growth cycle. That's correct. System looks up the seed types profile to determine the initial stage and the default values. So this is something that I thought was interesting that I had forgotten about. It does make sense to store the initial stage and the default values on the seed type profile. There's a concept inside here called a seed type, and that seed type has a recommendation engine behind it, and it makes perfect sense to design it there. So I actually like this design. It makes sense. That's where I would put it if I were doing this by hand, right? An initial stage transition audit record is created. By the way, I didn't ask for audit records. I don't really know if I need that. So we may tell it to not worry about that. That seems like it's maybe overreaching a little bit. But again, we're iterating right on the output after plan mode. Key design decisions, snapshot pattern, growth cycle copies the loadout data. Loadout foreign key is nullable. Now, I don't like this, but let's argue for a moment. I hate nullable foreign keys. I just generally think it's a terrible idea. Instead, you can use what's called a junction table. So we're probably going to tell it to use a junction table instead of a nullable foreign key. How would I never would have known that unless I had like 2 decades of database experience behind me. Now, again, a nullable foreign key isn't necessarily wrong. It's not a terrible design. I just personally don't like it. Do y'all have any comments on that while I get some coffee?
No, I agree with you on that. I would prefer the junction table as well.
So we'll tell it to do a junction table in a minute, right? Seed type foreign key is restrict. We can't delete a seed type that has growth cycles, data integrity over convenience. I actually think I agree with that. That kind of makes sense. Yeah, that makes sense. Stage transitions are append only audit log. We don't need an audit log. We're going to get rid of that. So we're just going to tell it not to do that. What's implemented? So currently we have full CRUD on this. We have a state machine validation, forward only, no skipping stages except where germination can skip blackout. Transition endpoint with harvest wait required for harvest. That's interesting. That's a lot farther along than I thought it was. Terminal stage protection. We can't update a transition from harvest to failed. Watering events. Now, again, these I didn't know it implemented those. Those are one of the more difficult pieces of the timer app. So we might actually have to tell it to back that out because I don't really know how far it's gone yet. User isolation. Ownership checks on all operations. That makes sense. That avoids IDOR attacks. Let me move my Zoom thing. Let's see what else. No seed data. Okay, what's partially implemented and missing? This is very interesting. No seed data for growth cycles. The seed file creates loadouts, but no growth cycles. That's okay. We don't really care about seeding data in my user quite yet. That's a thing we can do later. The check growth cycles medium type constraint is stale. Migration 16 only allows Cocoa Core, but the app validates all 5 medium types. This was likely never updated when medium types were expanded. That's good. We do want to actually update that, but I feel like that's a separate concern, not really kind of part of this whole implementation cycle here. No date time tracking per stage. I actually like that a lot. We do want to have timestamps on each stage's transition point. No integration with seed type profile timing. Profile has germination days, blackout days, active growth days, but these aren't used at runtime to suggest when transition, blah, blah, blah. So I don't think we need to worry about this quite yet. So given what we know and what it knows, I'm going to throw this to Jay Wood and Scott. What is the first thing you think we should do given all of this information? I have my own opinions, but I'd love to hear from you.
Is this you created this in plan mode?
No, I just asked it to look at it and tell me what's going on. I didn't pick a mode.
Gotcha.
Which frankly, I think is how most people are going to use this thing. They're just going to talk to it. Like, I don't know. I'm not in the habit of swapping to plan mode yet. Maybe I should do that.
Yeah, I mean, I mentally think of it. I don't think of going into plan mode, but I do ask it to make a plan oftentimes. It depends on how big of a feature I want to build. Like if it's going to be pretty straightforward and I want to really look closely at it, I'll just say, let's plan this out and I want to see what steps it's going to take and I'll have it go. But for something, if I wanted to let it go, like a lot more people are kind of building things where they want to kind of give it more runway so it can kind of do more things on its own. Another approach I've seen is where they actually create out all the different tickets. It actually creates tickets that might use something internal like beads, which is very common for AI these days. And it'll actually just create a whole bunch of tickets with dependencies and descriptions of what to do, and you can look at that. And then it makes it more independent. So it can kind of go, I'm going to implement this, then I can test it, and I can make sure that what I implemented matches the specification of each one of those tickets. And it gives it the ability to kind of go and take a lot of multiple steps. Not what we should do here, I don't think, but it is a way to go.
That's more of a spec-driven development, right? Which I think is the thing that you see. Like spec-driven development is coming up and coming. It's a thing I think Uncle Bob is testing, and I've seen Kent Beck talk about it a little bit too. So I certainly think that's a very valid approach. At that point, unfortunately, developers' jobs are validating specs, which doesn't sound particularly exciting. But go ahead.
Yeah, I think I think you called out some things that maybe it shouldn't be worrying about, like the audit records, the loadout, foreign key is nullable. Was there one other thing?
The tests are failing. So
yeah. However, that's a case where like we got to choose one or the other. Like if we want to fix the test, then trying to deal with like this where we're going from here. Well, I mean, I don't know. The context that I see here probably isn't useful for fixing those tests.
No, it's not.
So this would be more like what I see here is like we're kind of heading towards a plan, because you just used it to kind of investigate where things stand, and it kind of made some suggestions for how to go forward. Or wait, is it already doing that? Oh, yeah. So it already made the records.
Yeah. There are some things that have been implemented that we technically might want to back out, right? Again, this is a real world scenario when you're using AI, like especially if a junior developer like me is screwed around with it and had to put a bunch of crap in your repo. So it makes perfect sense for us to go through this.
Yeah, personally, I'd probably just go and start listing out the items that I want to change, and I would iterate on it to make sure that this document looks just like I want to, and then kind of move into the plan phase.
So I'm going to say let's modify the plan. Go ahead.
Yeah, or let's come up with a plan because I don't know that this was creating a plan in the first place. But yeah, like create a plan to like remove this stuff. I think tackling that first is probably the best play because we have code. like any of that code that's there that we actually don't want, such as the audit records, is going to, like the AI is not going to be able to distinguish whether or not that's important. And so if we don't think it's important, we need to just remove the code. Because the next time you start with a new context and it scans through the code base, well, it's going to see that those audit records that are there and just assume that they're supposed to be there. So I
Right.
think,
Well,
yeah,
I would just
focusing
simply
on,
reuse this. I would reuse this context in a
oh yeah,
countering.
yeah,
I would
for
reuse this
sure.
context so it knows it was deleted, right? It knew that it did those
Oh, I
changes.
see.
I would not start a
Yeah,
new context here.
but what I'm saying is like you will make new contexts in the future.
Yeah, for sure.
And when those scan through the code, that's what I'm talking about. Like it's going to
Yeah,
see
for sure.
this code and just assume that it's important because it exists.
All right, so we're going to do two things actually. So first off, I want to try and multitask. I'm going to come over here to a new Claude instance, and I'm going to tell it to fix the tests. I'm going to tell it to do this on a totally different branch because we're doing plan mode in the other one. And there's this concept of workspaces, which I'm going to be honest with you, I've not installed anything workspace related. I know you can kind of run two things at the same time and sort of, have one work on one branch and one work on another branch without them sort of munging up the same directory, kind of a limitation of Git, I suppose. So what we're going to do is I'm going to have it fix the test through this prompt, and then I'm going to bounce to the other one, and then we're going to continue our conversations around the plan, which makes perfect sense, right? So what are we going to ask it to? We're going to say integration tests are failing on a clean container after running make Docker reset. Please create a new branch. I don't know why I tell it please. I guess I'm just polite. Please create a new branch and run/fix the tests. All right, and now we're going to let that prestigitate.
Now, I
while we
would say just one thing I would add here is that when you did run the tests outside of it, unless you wanted to go ahead and run them again, in which case
Oh yeah.
you're not going to save in those tokens. I probably would have just grabbed the failed test and done a copy paste in there and say, here's the tests that are failing. Focus on
That's a good
There's
idea.
there's a good chance that it's going to do that process you just described itself to
Yeah.
see
Yeah.
the output.
That's a really good idea, and a thing to remember is you can copy paste the output, or maybe here's an idea. What if we were to tell the make file to pipe all of the output to a file
Mm,
after each run, and to replace that file after each run? So now instead of me having to go back up to my
Yeah.
terminal and do all this garbage where I copy pasta, again, Linux nerd, let's just pipe that straight to a file. So
hmm
there's a feature, right? That,
Yeah.
that we can tell Claude to go and implement for us later. After each test run on the make file, I want you to pipe all the output to the standard out, but I also want you to pipe it to a file so that we can use that, and I can just simply say, hey, go read the standard out file to look for the test failures and go fix the tests, right? That would save me some tokens. Again, look at
I
what we're
would
doing,
actually,
iterating
Now
on how to use the machine.
that's so simple though that I wonder if we could just do that by hand. Like that's just like a T call, right?
It is a T call, but I don't remember how to do T. I would go
Fair
Google that.
enough.
See, I don't have to Google anything anymore. I totally know how to do
yeah.
pipes in Linux, but I just don't remember the exact call. But anyways, all right, so let's go back to this. So while it's prestigitating, let's talk about what we're trying to do here. So we're modifying the nullable foreign key to use a junction table. I'm just going to tell it that. Could I get more specific? I could, but I want it to come up with a plan, and let's iterate a little bit. So I'm just going to say that to it. The second thing is we don't need any audit tables. Please remove
Audit records,
audit records.
since that's what it called it. Like we
Yeah,
don't.
yeah. Well, I
I
mean,
mean,
usually
presumably it's a table, but
It
I don't
would
know that we
probably
know
figure it
that.
out. Yeah.
I'm going to do a slash, any audit record tables. So please remove those from the plan. All right, what is the third thing we need to do here?
Something to do with the bottom part, the partially implemented, I want to say.
Oh, okay, yeah, yeah. So, watering event tests exist, but there's no gross set. Okay, so let's just say, so we don't. Let's just try this. I'm gonna say I don't want to do watering events yet. So let's tell it to remove everything related to
Mm-hmm.
watering events because I feel like that's a separate feature. Yes, I could tell it to do the whole thing in a giant chunk, but I think that's gonna do too much cognitively for us to figure out. We'll be sitting here reviewing code for hours if instead
Right.
we just told it to do a smaller chunk of work, which is again a very key thing to do here. So remove all code related to watering events. I want to do that later. Is there anything else we want to ask it to plan? Well, let's finish this prompt. So what else do we have on this prompt, or is this enough?
I think that might be it.
Okay, do we want to be now? One thing I have had problem with. Do we want to be specific on where it puts the plan? Sometimes
No.
it's good to tell it to put it in a markdown or not. You guys are cool with that? We just go.
Yeah, I would just.
Because usually it's not something I care about keeping afterwards. And so wherever it puts it, as long as it remembers where it is, and it's somewhere local.
Mhm.
I have had it forget plans before, especially.
So it does. It stores them in your .claude, the user
Oh, it
directory
does.
.claude folder. I believe they get cleaned up after a while, so like eventually it will get
Mhm.
destroyed, but it'll keep it around for a while.
Then we'll just go for now. All right, let's pull the trigger. Let's do the thing. All right, let's head back over here to our tests. Oh, good Lord. Oh, no. I hate this.
Did it
Although
try to run the tests? It tried to
yeah,
run the tests.
I don't do YOLO, by the way. I never do YOLO, just because it doesn't make sense to do that. It says unit test pass. All failures are in test password reset integration. The root issue is returns a 400. Let me investigate. So it is doing the thing, but I guess I probably should have done YOLO for the webinar, but no worries. Let's just sit here and tell it yes a billion times.
Maybe
Nah,
it'll
we'll
come
get
back to
there.
me.
No worries, we'll get there. So
I would
this
say
is
with
another
respect to
interesting thing.
YOLO,
So we're kind of doing two things at once, and sometimes I've found that's a problem. Like for me specifically, doing two things at once can cause some serious issues because my brain doesn't switch fast enough going between the two of them.
That's where I
Um,
like the desktop apps for this because they track the threads in a
mm,
more like they kind of do the chat
mhm,
GPT thing where it like generates a title for the task before
mhm.
that session. And so
All right, so here we go. All right, we have a full plan, and we're going to table the integration test, which is kind of cool. I actually going to want to go back to that before we end and kind of look at it and figure it out because I do remember having a conversation with Claude about using UTC everywhere because I've run into time zone problems so many times in my life. I'm like, make effing sure you're not storing local time in the GD database, Claude. Please, for the love, do not store local time in databases. So we'll go and look at that in a minute. But this is a really chunky plan. So let's kind of look at it here. So the grow cycle feature is partially implemented. Before adding more features, we need to clean it up. The nullable loadout ID on growth cycle should use a junction table. All right, matching. Oh, okay. So that is actually pretty cool because I did tell it. It tried to do a nullable foreign key somewhere else. So, but this is a different context, so it didn't learn from that. I don't like nullable foreign keys. Tried to do this somewhere else, and I told it to do a junction table. So that's interesting.
so just real quick that
Mhm.
if you're seeing something like that, where it continues to like write things how you don't want it, that is the signal that hey, maybe we need something in our Claude MD file
Mhm.
for stopping this behavior.
I think that's fair. There are times where a nullable foreign key makes sense, but it's rare, in my
Mm.
opinion. So I would certainly consider that to be something I would put in my claude.md, 100%, just because I don't like them. I think junction tables are more
yeah.
flexible. They give you other
Mhm.
design patterns that you normally don't get. Because the problem with a nullable foreign key is that entity is getting bigger and bigger and bigger and bigger, and you're adding more things on it, and you're putting a relationship on the entity itself. If you're thinking in terms of how to design a good entity model in a database, sort of in a classical BCNF form, you're going to want to hang certain attributes off of the relationship between entity A and entity B. It just
Yeah.
makes sense. Like state transition should always live on something like a junction table, just because it's more flexible. It's not that it's right or less more right than putting a nullable foreign key. It's just a more flexible design. And this is
Yeah.
a great example of a questionable practice that maybe you should, if you know how it works and you understand how to implement these types of things, put that in your MD file, or even build out an MD file for your entire organization and say, okay, this is how we do stuff because it makes more
It
sense.
does make those junction tables do make queries harder though
They
to
do
write.
make queries harder. They make queries a little bit more less efficient. They make them harder, which is again why you have to kind of think about it. And maybe it's not a blanket catch-all. Okay, never use nullable foreign keys, right? It might make sense in certain cases. I like him because again, if I'm extending the relationship, I want a place to hang off those extra attributes.
Mm.
But yes, it does make it harder.
Well, and
Three
when you
commit.
do, if you change your mind later on, you want to add those features, then all of a sudden you'd have to do more of a
Mhm.
destructive schema change by getting rid of a foreign key column and everything else.
Correct.
Whereas when you have the junction table, you can just add to it.
Yeah, dropping columns is a nightmare. Like
Mhm.
it should be a thing you never ever do.
Exactly. And if
And
you can avoid that, it's so much better off in databases
right.
just to keep it
Mhm.
I like
right.
to spend more time with good database entity model design than worrying about dropping tables later. This is one place where I think going fast isn't necessarily a great idea. You do want to build out the right model. But again, that's my
Mhm.
personal opinion. Remove watering events. So, okay, three commits, removing the watering events, removing the stage transitions, and replacing loadout with a foreign key with a junction table. So this is the three things it wants us to do. I think that makes pretty good sense to me. So it's deleting these files, it's editing the handlers, it's editing the DB helpers. And again, so here's a challenge. Here's a problem. I don't know that this would remove everything. Why? Because
Mhm.
I don't have the whole code base memorized. What I used to do when I was writing code like this is I would have the whole thing in my head. I don't know if you guys would do that too, but if it's a sufficiently small service, I would know where everything was just because I had written it and I knew where it was. So I don't know that this is everything. So we might have to go back and ask it again after we
Mhm.
go through this implementation and say, hey, can you double check and make sure there's nothing left in the watering events? Don't trust that it's going to get everything on the first try because it's not in most cases.
My memory's always
Um,
been like Swiss cheese, so I'm always, even in the case of code that I'm more familiar with, I'll be grepping around to double check where, where do I see water and find out could it possibly be related to that feature. So in that case,
exactly.
I would fall back on the AI, create an agent or something along those lines, a sub agent to go and review, did we actually delete everything we needed to remove this feature?
I like this. Something I had this thing do previously. I have a front end for this written in React that I've also Claude coded. And one of the ways that I've been able to keep the contracts in sync with the front end and the back end is I have the back end, and I even have an agent that does this that specifically designs or creates an OpenAPI.yaml file. That then on the front end, when I'm making modifications, I'll have the front end read that YAML file instead of going and getting context on the whole freaking code base. I'll have it go read the YAML file. And so go read the YAML file, figure out what the data contracts look like, and now you can figure out how to write and code against that. It's a way of saving context. I like using temp files as a way to communicate between, think of them as pipes in Linux. You want to pipe data in a very efficient way, and that's part of the engineering challenge with these agents that I've enjoyed is how do I get the most amount of contextualized good data to the agent so that the machine can then go and produce a better result. And that's been super valuable to me is using things like you don't have to use OpenAPI. You could use a standard Markdown document. Like I like OpenAPI because it has a grammar. Anything with a grammar, an AI is going to be much better at understanding than obviously LLMs understand free text language, but grammars are much more interesting to machines. They can make better decisions on them.
Usually
Step two,
saves tokens as well.
it does. Step two, delete a file, edit the growth cycle stuff. This makes sense. Edit the handlers. Again, we're getting rid of all of the stage stuff. Again, this is dangerous because we're asking it to remove like portions of actual working APIs. This might break. Just red flag for me. Growth cycle is going away. DB help. Okay, again, we're moving. So one of the things that I've seen here, this is interesting for y'all, and we're going to let it do this, but this is not in production. So if you think about how migrations are built, they go one on top of each other, right? And that's the whole point of a migration. When we're not in production yet, what I will do is I will let it do this to get the database in a valid state, but then I will go back and tell it, hey, I want you to look back through all of the migration files. We're not in production. And I want you to refactor and remove migrations and put them all like flatten the migration tree. This is a thing that's super useful because then you don't, the way that the migrations stack, you have more of a chance of causing a conflict and a problem, right? Because you're stacking A over B over C over D. And sometimes it can get really confused and the state in this migration one F's up the state in migration 19. So this is one of those things that I never would have done if I were working without agentic because I would have simply been, well, I'm just going to write the migration because I don't want to deal with it, right? I don't want to go back and flatten all these migrations. It's a waste of my time. I don't want to spend 3 hours flattening these migrations when I just need to get my features out the door. With agentic, it's a task you can hand it and walk away, and it oftentimes does a really good job at that. Verification. All remaining tests passed, count drops by 12. That's cool. I like that it called that out. Verify no compilation errors. That makes sense. Spot check on a grep. That makes, oh, hey.
It says approximately 12.
Approximately. Okay, well, yeah. So Scott, that's exactly what you said you would do, right? Is to grep through the file looking for watering events. The loadout ID looks good. Okay, so I think we just go. Do we need to clear our context though?
Yes.
All right.
I would say in general, when you're using a plan, clear the context because like everything, the idea with a plan is that everything it needs to know is in the plan and anything it doesn't, or that it needs to know that's not in the plan, then it should just look up. And it's not spending time or tokens doing discovery that it already did and created a plan to describe.
Honestly, it's one of the great things about using a plan is it gives you that reminder and opportunity to clear the context and feel safe doing it.
Not only that, what I would actually, and this is not easy to do with the CLI, but I would generally have it. I would just like start a new session or whatever it needs to be done to change the model because I probably used Opus to create the plan, but once you have a good solid plan, you generally don't need Opus to implement it. Sonnet is more than capable of implementing plans. I haven't seen much of a difference other than it being faster. And
nice. I've not played with that at all. So that's a great thing to know. Again, I'm using this like a dumb CEO would use this, right? I'm just going in and typing stuff and telling it to do things. And so far it's done a pretty good job. That's a really good idea is to think in terms of what model you're using. So when I'm building out my agents, I like that you can select which model aligns with which agent. I felt like that's been pretty interesting for me. And notice we're not even spinning up any of the agents I have configured here, which is the thing that I've yet to kind of crack. Do you guys have any best practices kind of on that? I usually find that I just tell it to do a thing and then it produces a bunch of stuff. And then I forget that my agents even exist. It would be nice if it knew when to spin up an agent.
So my recommendation is to not create agents for that and instead use a file tree system. So this guy, I think we had talked about this, that video where this guy is showing off this file tree approach because the idea is with the file tree, it's like you basically create file tree with different sets of instructions that are organized by subdirectories. And when it needs to do something, like you have your claudemd for example, like it would start there, and then that acts as a table of contents to go to the right place that describes how to do the task that it's trying to do. The really nice part about this is that when you set it up this way, it's portable to any agent. You don't have to like build this for Claude and then it's like, well, I don't want to use Claude anymore. I want to use Codex. With Codex, you can use the file tree approach that you already made.
Got you. So now I have a bit of a conundrum, and I want to figure out how to do this. So I was dumb, and I went ahead and had it start implementing. But I forgot to do a PR for my current unit test fix. So my unit test fix is sitting on a branch, and this change, and this is where I messed up, this change is actually going on a branch too. I don't know which branches these things are being run on.
We're not using work trees, so it's probably done some weird stuff.
I should have used work trees, right? I'm not using work trees because I've not looked into that. So I guess this is a big thing. And I've run into this a few times. So the first thing I'm going to do when I'm off this webinar is go install and look at work trees because that makes perfect sense to me. But a good thing to note, let's look at how it fixed it. Again, this is just a webinar. So what did it do to fix it? So it added this line. So we went to .utc. That looks interesting. And then all of my handlers on the password reset test are now just doing UTC add 15 minutes. Which makes perfect sense. Now, I wonder why that failed because these tests were running perfectly fine probably 3 or 4 days ago. So I don't know why that
Was
would have
it
failed apart from
prior
some.
to the time change?
Yeah, actually, you know what? That's it. It was prior to the time
Okay,
change.
there you go.
It's bug,
Every
right?
time.
Every time, freaking time change, man. Go.
But it's a great way to find bugs. Maybe we should change the time more often.
So we're gonna let this thing kind of spin down. We're kind of running up against the end of time here, and I don't see any questions in the chat. Which this was kind of again, this was designed to be a let's hang out and write code kind of thing anyway. So I hope everyone got some interesting knowledge from this. I certainly learned a thing or two. I do think that the name of the game is that we spent more time talking about the prompts and the best way to get the machine to produce the output that it did than we did writing code, which I think is interesting and useful. I think if I were sitting here doing this myself, it would have been a little bit overwhelming for me to parse everything. I would have been more likely to rubber stamp. And let's all be honest with ourselves. You're probably a lot more likely to rubber stamp a change if you did it in a vacuum and then send it up on a PR. I like the fact that I had two smart gentlemen sitting here with me working together on this change, and note that we were bouncing off each other and producing more better ideas on how to do things. Jay Wood was giving his experience, Scott was giving his experience. I was sitting here effing everything up. So I think overall it's a much better experience to do this with other humans. I could also imagine a world where we had a product person, like if Lou or Sarah were my product people telling us what to do, their eyes would be glazed over right now. But eventually they would be saying, wait a minute, does it do the thing I asked it to do? And it kind of produces an interesting little pod of humans to build software. I think it's a new way of doing things, and I'd love to see more about it as we continue to kind of drive forward in this new frontier that we live in. While it's wrapping up, Jay Wood, Scott, y'all have the floor. Do you have any other specific ideas or things that you've seen that we want to kind of let our audience know about? And then we'll wrap this up.
Um,
I guess I would only add just that there's a lot of people trying different ways of doing things, and some of the people who are using multiple agents and they're trying to coordinate between the agents doing various kinds of orchestration are trying to find different ways of doing things like specifying models per agent uh,
Mhm.
for different skills and all sorts of things like that. And I think there's a lot going on in that area, and I think that's probably where a lot of power comes from when you figure out how to harness it well. Especially when you start creating these independent agents that are very, very good at doing things like reviewing, not just writing the specs, but reviewing the specs, making sure the code is consistent with the specs, making sure the tests are consistent with the specs, making sure that there's no gaps there. Have some agents whose entire job is to be that really picky, persnickety one that says, "Oh, you didn't do this, or you missed this edge case." When you can do that, you can have a whole bunch of different agents, and you can let that go a little bit in your mind and start focusing more on the bigger picture design and architecture. That's going to be really powerful. But how to coordinate that and making sure the guardrails are in place is still what I think people are trying to figure out.
I like that it ran all my tests after commit on step one, 488 test pass, never going on to step two. This is the XKCD sword fighting on the chairs version of the show, or a portion of the show, right? Where my code's compiling. We're not compiling anymore. We're just sitting here watching an agent produce a bunch of code. I see why people do
so
this at night, right?
I'll add another thing, which there's a topic floating around that's gaining some popularity around cognitive debt,
Mm-hmm.
and this just gives kind of an example to talk about this.
Mm-hmm.
So cognitive debt is sort of like technical debt, but it's invisible. So technical debt's visible in the sense that it's like, hey, we don't have tests for this. We can see that, or the tests are flaky. That's these are very obvious signs that things need to be improved, and we have debt that we can track that would track like what we need to do to go fix that. Cognitive debt, on the other hand, is kind of what happens. Like, say you have a senior engineer who's written most of a system and they leave the company. Now no one knows how this system works. That's cognitive debt.
Yep.
We're seeing this more and more with AI. As AI writes stuff, we're kind of getting to the same situation. So it's really important to understand what you have created, to the point that there are some practices that I want to investigate around, like discipline of AI usage discipline, where you make sure that your team like understands it, because something that often happens with AI is it writes something and then you go back and look at it and you're like, well, why did it do it this way?
Yep.
And it's like this doesn't. It's like there's a much easier. You might think there's a much easier way to do this that would have made a lot more sense. And so when you end up with a lot of the why would it do it this way, you might end up scratching your head a lot more, and that's just a sign that you've got cognitive debt. So just taking the time to like really understand the code, I think it's still important. And now, obviously, this project is not in production, as you mentioned. And so this is kind of the perfect place where you can just play around with AI. But when you're talking about production systems, it's kind of a different story. So
Yeah, for sure. So the counter argument to that I've heard is that one day AI will be just like compilers for business logic, where if you think about how a compiler works, none of us cares about the cognitive dissonance between how a compiler does dead code elimination versus how the code we write turns into dead code that has to be eliminated, right? Or how parallel processing of specific data elements occur when you're doing like crazy parallel loops, and how the silicon interprets the registers and turns the opcodes into the lightning rock thinking for you. I think this is totally different though, in that I don't agree with that analogy. Maybe one day we get to a point to where again AI is so powerful that it can wholesale produce workable executables similar to how a compiler produces an executable out of code itself. But for now, that's not really on the table. And I think, as you said, Jay, what it's extremely important to understand what the system is doing, and to have the operators of the system, the operators of the machine that built the system, i.e., the developers in your organization, they have to know what's going on. Do they need to know? And again, Jay Wood and I may differ a bit on this, which is totally cool. I don't think you necessarily have to have intimate knowledge of every corner of the code, because you can simply ask the machine to tell you about it. But I do think that you need to conceptually understand the practices we described at the top of the conversation, right? When I said I don't like for nullable foreign keys, another engineer and I could argue for 20 days on why we should or shouldn't do nullable foreign keys, and then eventually you would come to a decision and implement it. I just don't like it, so I don't want to do it. But those are the systems level arguments that you should be having now, as opposed to should this line be 50 functions or not, which I argued for two to 3 years ago. Now we're arguing over what's the right systems level design problem. Like, should we be using queues? Should we be using certain specific patterns inside the code? Like, those are things that we should be talking about now. And I think it's more powerful to teach your
Yeah.
engineers, and the senior developers on the staff should be teaching those journeyman, journeywoman level engineers. Here's how you think about designing software systems, not here's how you think about writing code.
No, I
Yeah, I
will say,
think
I think I heard on a podcast just yesterday, in fact, people talked about how back in the days when compilers were a new thing and most people were handwritten assembly code, they doubted the compilers. They would go and review the assembly that it generated. And that went on for some time until finally it got to the point where it was good enough and reliable enough and consistent enough. I think we're still at that very, very early phase where we do need to
mhm.
review it. We have to know what it's saying. But there are going to be certain things, kind of like that decision. I think at some point you're going to get to the point where it really won't matter that much early on in systems design whether you do go one route or the other, because the right way will be so kind of by default, not even just the right way, but it's the safest way. And there'll be a lot of things that can be built where you can trade off not having to worry about whether or not that decision was important, because by taking one choice instead of another saves you so much down the line that even if it might be slightly less efficient, it's a benefit for the design and the code in the long run. And those types of things might start to happen more often, making it easier for us to trust what it writes. But we're not
It's
there
it's
yet.
about it's about the economics of software. Like, I've said this for a long time. Like, I think 4 or 5 years ago, I remember having during interviews and when I'm talking to customers and sort of thinking about the value prop that Seven Factor brings to the table, being able to identify when the economics of that trade-off, like not the economics in that the dollars and cents and financial stuff, but the economics of the trade-off that you're making. Like, when you're building this feature, and this is the thing that we challenge product people to, and we have these conversations inside product organizations and inside our organizations all the time, is does it make the most sense to do this or not? Like, from a market value perspective, from a business perspective, is this the best use of your engineering team's time? Similarly, like inside the engineering organization itself, we used to the big reason why you would write tests and you would build things the right way and you would have high quality is, one, to reduce your downtime in production, but also to increase the productivity of those people around you.
Yep.
So when I write a small tiny function and write a bunch of tests behind it, it's not that I'm doing that to reduce bug count. That is an outcome of the practice. The point of the practice is so that when Jay Wood looks at my code, he's like, I get what Jeremy was doing here. It's wrong, but I get what he was doing. Or hey, what if we made some slight tweaks to this and I run my test and everything runs fine? Like it's about the trade-offs of cognitive understanding, or cognitive, what's the word? The speed at which you can understand that code and add more features to it. That's the whole reason
Mhm.
you're doing that, right?
Yeah,
So
that's the thing behind cognitive debt. It's like you need to be able to understand it. It's like you don't have to understand it, but you need to be able to understand it.
exactly. I agree with that 1,000%.
That's
And that's
really
what
well
I
put.
think that's the next step. And I think even if AI code generators become compilers of business logic and we're all doing spec-driven development, you're still going to have a team of engineers that have to know how to operate the apparatus. And it might just be a slightly different world where instead of reading, 50-line functions and running linters and all this, we are instead QAing the outcome and the systems level outcome of the machine, which changes the profession dramatically. You still need to be able to read code. I don't think we'll ever get to a point. Well, I say I don't think we might, but let's just assume for a moment in the next 10 years when I'm still in industry, we're not going to be doing that. Afterwards, I don't care because it's not my problem anymore. But I think it's important for you to encourage your engineers to learn the systems, learn how to use these things, but also learn the outcome of the system and learn systems level thinking. thinking, which excites me because that's what I've always loved about being an engineer. It's not that I'm writing code. That was the boring part. It's the systems level thinking where I'm coming up with these crazy features and I'm taking a real life business process, not a well, a real life growing silly microgreens in my basement process and turning it into software. Like I never would have started this project if because it would just be too much work. Like it would take me
Right.
weekends. I'm not that in love with my freaking microgreens in order to write a piece of software that does this for me. And now it's so cheap for me to sit here and pay for a Claude subscription and talk to the machine for a couple of minutes and then QA the output 3 or 4 days later. That
Yeah.
it's incredible what I can do now, and I think that's of immense power.
The
So
people I've seen that are really, really into the into doing things using AI, who traditionally were very, very good hands-on coders, are looking at it kind of like as a distinction between programming and coding versus building. I think I heard Peter Steinberg, who created OpenClaw, talking on a podcast saying, "I love building things. I want to build tools." And before I was good at doing it with code, but it slowed me down. Now I can do more. I can build more things, and there's still a lot of really important things I have to think about when I'm building it. But now I can see the outcomes so much more frequently, so much more often. It just makes me more excited. But we're still responsible for what we build.
all right. To great. To wrap it up, we finished. We got all three of our commits. I am actually going to go and figure out how to unwind the fact that I have two separate pieces of work on the same branch now. So we're going to figure that out. Hopefully, it didn't completely F it up and do some weird stuff. But again, the whole point of this was to give people a taste. I'm sure most of you have already experimented with this. But I'm pretty pleased with how we landed. I will obviously QA this and make sure that it is not absolutely psycho crazy, but it looks pretty good to me. And again, it doesn't matter if it's completely wrong because I can just have it do it again. So thanks for everybody for your time. Jay Wood, Scott, thanks for joining me. This was a great conversation. I enjoyed it. I had fun. I hope you guys did too. And we might do something similar on the next one. We're trying to figure out what might be next for this. But this particular, the things we covered here is walk into a code base with things you've never seen before, spin up a context, add it to add some things, look and kind of check the understanding, check the output, look at the plan, and then modify. And also, it fixed my test for me and found a really weird UTC bug. So proving that AI can in fact fix time zone bugs, which is great. That means it's better than most humans. So thanks, guys. We'll see y'all later. Appreciate it. Have a great rest of your week.